7.4 is on nth roots. I still haven't eaten. A square root is really a second root. Okay, when we talk about square roots, it's really like there's a little 2 on this shelf sitting up here. When we do a square root, it's really a second root. We're talking about things that are degree 2. A cube root would be something that's of a degree 3. If there's no number written on this little shelf here, I call that a shelf. If there's no number written there, then we know it's a 2. But if there's a number written there, then right now we're doing a third root. And there's 4th roots and 5th roots and any type of root, even a 9.3rd root, anything you want. So a 4th root is really saying what to the 4th power equals 16. So in this case, the 4th root of 16 is 2, because 2 to the 4th power is 16. The 5th root of 243 is 3, because 3 to the 5th is 243. We do all kinds of roots asking basically what to this power, what number to this power equals this number. One thing I want to square up right away, or clear up right away, square roots and 4th roots and 6th roots and any even root, those are the ones that have a plus or minus when you're solving. So if I said that x to the 4th equals 16, well, that means that x could be 2 or x could be negative 2, because both 2 to the 4th equals 16 and negative 2 to the 4th equals 16. But if I just said, what is the 4th root of 16, then I just put a positive 2. Here, in this case, I was solving. I was answering the question, what numbers for x would solve this equation? But here, I'm basically just given a math problem where it's saying, what is the 4th root of 16? The 4th root of 16 is 2. If I wanted the negative 4th root, I would write it like this. The negative 4th root of 16 is negative 2. That's when you have to deal with the plus or minuses. Plus or minuses come when you're solving. If x squared is 9, then x equals plus or minus 3. There's your plus or minus. When you're just calculating a square root, that's kind of what I was talking about here, I guess. When you're just calculating a square root, what is the square root of 9? We just say 3. Okay, we're going to simplify radicals. We've talked about this before. I've talked about doing a factor tree where I can find things that multiply to 80, like 8 and 10, and 8 is 4 and 2, and 4 is 2 2s, and 10 is 5 and 2, and I look for pairs, I look for doubles. There's a pair of 2, it comes out as a single 2. Here's a pair of 2s, it comes out as a single 2. And this poor little 5 has no pair, so it stays behind in the radical, and we get 4 root 5. It's not the only way to do this. You know, what that's really saying is that 80 is really 16 times 5, where 16 is the biggest perfect square that goes into 80, and the square root of 16 is 4. This is kind of the faster pro way of doing it, but most people like to do it this way because we've got a system they can follow. But if we tack on variables like this, not much really changes. If I want to find this square root, I'm going to simplify the 252. And 252 is 2 and 126. And 126 is 2 and 63. And 63 is 9 and 7. And 9 is 3 and 3. If you divide things in half as long as you possibly can, these factor trees can get pretty simple. Here's a pair that comes out. Here's a pair that comes out. Poor little 7 has no friend. So that's 6 root 7. But then I also have to deal with this x squared. What is the square root of x squared? Well, that's just x. So really, an x is going to come out of this radical also. So my answer is actually going to be 6x root 7. The square root of 252x squared is 6x root 7. 18 is 9 and 2. 9 has 2 3s. So it's going to be 3 root 2. And then x to the 10th is really x squared 5 times. So there's 1, 2, 3, 4, 5 x's. It's really 3x to the 5th root 2. The shortcut there is obviously I can take this 10 and divide it by 2, and that's how many x's come out. 5 x's came out. I'll do one more example of this. 120x to the 7th. Well, if I break down 120, 10 and 12, 10 is 5 and 2, 12 is 4 and 3, 4 is 2 and 2, there's a pair of 2's. Nothing else has a pair, so I'm going to have a 2 on the outside, and inside I do 5 times 2 times 3. Boxes make it more clear. 5 times 2 times 3 is 30. And I take x to the 7th. Well, 7 divided by 2 is 3.5. I don't really want to think about 3.5. I want to think about the whole number. 7 divided by 2 is really 3, remainder 1. So that means that 3 x's are coming out, and 1 x stays behind. If there's an odd number of x's inside here, one of them is not going to have a pair. So you're not going to be able to take everybody out of the house. This little guy here is going to stay behind. We play the same exact game if it's a third root or any other type of root. We're going to take 40 and break it down. 40 is 8 and 5. 8 is 2 and 4. 4 has 2 2's. Now I'm not looking for pairs. I am looking for triples. I'm looking for groups of 3. So when I look for these triples, there's a triple. It just comes out as 1. It's really 2 times the third root of 5. This little 5 didn't have a date, it stayed behind. We're basically saying we're doing the third root of 8 times the third root of 5, but the third root of 8 is 2. Now we're going to play with these x's. If I do 5 divided by 3, 5 divided by 3 is 1, remainder 2. I don't know why I wrote that 2 like a square, but I did. It's 1, remainder 2. So 1x comes out, 2x's stay behind. It's 2x times the third root of 5x squared. That might not actually look any simpler than the original expression, but trust me, it is. If you want to try this next one on your own or in advance, you can. Pause it now and go for it. 32 is a whole bunch of 2's. I look for triples. I'm looking for 3 of a kind, groups of 3. Here's one. They come out. These are not triples. They can't go. They stay behind. 2 times 2 is 4. I'm multiplying those, not adding them. Make sure you multiply them. Okay, well now I'll do the powers. 10 divided by 3 is 3, remainder 1. So 3 x's come out. 1x stays in. 12 divided by 3 is 4, remainder 0. And there's my simplified radical. One more like this. 270. Well, 270 is 27 and 10. I know that 27 is 3 3s. I'm just going to jump straight there. And 10 is 5 and 2, which doesn't really get me anywhere. So these 3 3's come out, and the root 10 stays behind. Now, 12 divided by 3, we just did this. This becomes x to the 4th. 5 divided by 3 is 1, remainder 2. I just treat that y plus 3 like it's a variable, like it's just something that I'm going to take this power and divide by 3. And so that's how that simplifies there. Your book for some of these, for the square roots and the fourth roots and stuff that show absolute value, don't worry about that. Here I'm doing a fourth root. I'll just do it once, even though we should get the idea now. I'm going to look for groups of 4. So I have 24 and 100, 4 and 6, 2 and 2, 2 and 3, 10 and 10, 5 and 2, 5 and 2. There's 1, 2, 3, 4 2's. There's my group of 4 right there. I made that one. Let's try that again. This is a group of 4 2's. Take them out. Nothing else is a group of 4, so these things all multiply. That's 3 times 5 is 15, times 2 times 5 is 150. This stays behind inside my radical. 19 divided by 4 is 4, remainder 3. So that's going to be x to the 4th, and then x to the 3rd inside. The remainder stays inside. 10 divided by 4 is 2, remainder 2, which is 2, remainder 2. Okay, lots of examples there for you to play with. I'm going to skip this. I want to show how to do this on your calculator now. So I think I can skip this also. Man, let's go here. Do this on your calculator. To do a third root on your calculator, one way to do this, if I press this math button, which is right here, if I press this math button, this option here, the fourth option, is third root. So I can do a third root of 40, and a third root of 40. Whoa. We're going to do the third root of 40, so I press the math button. Don't press second, ignore that. Just press the math button. the third root of 40, which is 3.42. And if I were to do this factor tree, these all come out, that's really 2 times the third root of 5. This is how I can check to make sure my answer is correct. 2, times the third root of 5 should come out to the same decimal, and it does, so I know that I've done this right. I checked. This is a correct simplification. This is a correct decimal expansion. If I want to do the fourth root, my calculator doesn't have a fourth root option. It has a third root and a square root, not a fourth root. But this x root right here accomplishes the goal. If I press the number 4 first, and then I go to my math button and I scroll down to the x root, it's going to take this 4 and plug it in for that x. If you have a newer calculator, it might show that different and even a little bit easier. But this is how on my calculator, the fourth root of 4,000, and the fourth root of 4,000 is 7.95. Okay, let's talk about negative roots now. With even roots, like a square root, a fourth root, and a sixth root, if the number on the little shelf is even, like here it's a 2, you have to pull out an I. So the square root of negative 64 is 8i, and the fourth root of negative 64. Where is that? I don't know. So we'll do the sixth root. The sixth root of negative 64 is 3i. Nope, 2i, excuse me. 2 to the 6th is 64. 2, 4, 8, 16, 32, 64. Right. Excuse me, I apologize. That's going to be 2i. If you have an even root, like a square root, a fourth root, a sixth root, the negative numbers have to have i's. But if you have an odd root, you don't. Negative 64, the third root of negative 64 is just negative 4. Because negative 4 times negative 4 is positive 16, times negative 4 again is negative 64. Odd roots, like third roots, fifth roots, and seventh roots, don't have to have i's in them, but even roots do. I don't know what the fourth root of negative 64 is. It's probably something kind of obvious, but whatever it is, it's going to have an I in it. Let's actually calculate it. I'm going to do the fourth root. I'm just second enter my previous equation. Let's do the fourth root of negative 64, and I get a non-real answer. So I'm going to take my calculator, press the mode button, turn on the a plus bi stuff. So now I can do imaginary things. And it tells me it's 2 plus 2i. Yeah, don't worry about that. That's kind of something beyond what we're going to deal with. The idea is there's an I in it. Okay? So this is not going to have an I anywhere. I'm just going to go for it. So for negative 40 is going to have 4 and 10, 2 and 2, 5 and 2. There's my triple. So it's 2 times negative 2 times the third root of 5, then divided by 3 is 3 remainder 1, 12 divided by 3 is 4 remainder 0, and there's my solution. The negative can just come out, but if I was doing a fourth root of that, it would all be different. I would pull out an I instead of a negative. That takes care of it. Thank you very much. This one was also kind of